I'm a retired scientist from the Brookhaven National Laboratory. I don't know if you are familiar with Brookhaven at all. Okay.
Yeah, I grew up on Long
Um,
Island.
oh, okay.
Yeah.
Whereabouts?
Islip area, South
Okay. Yeah,
Shore.
I grew up in East Meadow.
Okay.
Uh, so um, I really spent my re career largely in, many aspects of radiation detection. And also emergency response. I was part of the radiological assistance program for almost my whole career and spent a little bit of time. I spent 3 weeks in Japan during the Fukushima crisis, and I've done many other things like that, in exercises and other deployments. So I have free time now, and I thought this was a good fit to contribute to the organization.
Wonderful.
I've known about it superficially for years, but like I said, now I have some time I could devote to this. If there's some way I can help the organization, I'm very happy to try and figure that out.
Well,
And I also still do work for the Department of Energy, National Nuclear Security Administration, as a contractor. So I'm still involved with radiation detection with them. Um, as you're probably aware, there's a large array of detectors in Ukraine, some of which are yours, some of which are Ukraine, and some of which are what the U.S. has donated to Ukraine. So we have a team of adjudicators, and we stand watch 1 week out of five. So when anomalies come in, we adjudicate them and not uh, you know keep them under the radar unless needed something that is above the radar. So as you can imagine, when you get a lot of stuff out there, things happen that are not real, and so we're the ones that take a look at that and identify problems, and then hand them off to the Ukrainians to fix them.
well, interesting. Very interesting, the work you're doing. And yes, surely I think you can contribute a lot. I mean, with all the knowledge, and we need people like you. This is perfect.
Yeah.
Are you also interested in hard and software, or basically more radiation related and organization wise?
Hardware really is my specialty. I'm not a software or a programmer person. That's not that's not my expertise.
Okay.
Uh, yeah, I'm mainly I think I'm most valuable on the operational side. Uh, and
You know,
also, if you have data that needs to be interpreted, that's really my specialty.
okay.
Mm.
And data from synthesizers too, or
Any
any
sort of
data?
very logical,
Oh,
I mean,
great.
yeah, radiation measurements and interpretations are one of the things that I do. I mean, in fact, that's what I did on my deployment in Japan. Um, as you can imagine, we generated a lot of data, and a paper that I had sent around. One of the things I did was, look at the data in terms of reality, because the people who were making the measurements were certainly competent and expert people to do that, because that's what DOE does. But more times than not, we do this in exercises. And in exercises, the data is not real, it's contrived. So once you have a situation like Fukushima, where it's it the the material is not spread out evenly like peanut butter. It's a more complex situation. So that's kind of the things that I was looking at in terms of sorting out issues with the data, because we're making real measurements, and it's not all that's not all that simple to get consistent data at times or understand the data. So that's the kind of stuff that I do too.
Okay. Yeah, that's great to hear that. And maybe Louis can introduce himself. Then Steve knows what Louis does.
Okay, hi. Pleased to meet you, Steve. My name is Louis Bertrand. I live a little bit north, in Ontario, near Toronto. I'm retired an engineer primarily, and then the last 25 years of my career teaching at the college level, not college university, but community college. So technicians and technologists rather than engineers and scientists. Teaching electronics, microprocessor, or embedded controller stuff, and software development with an emphasis on embedded software. In other words, the software that goes into little gizmos like our bGeigieZen. And one of my professional interests is software reliability. In other words, avoiding mistakes that crashed, microcomputers and stuff. And I retired in 2023 and was looking for something to do and joined Safecast, a really good crew of people, if I may say so, including myself. Haha. But and mostly we've been working on the Zen, first of all, firmware, and helping out with some of the hardware issues, and writing manuals. So I'm in the process of writing a complete assembly manual for the Zen kit, the latest version of that kit. As well, I did a lot of work, but the credit goes to Michael, and he can talk about that with the GPS, or the position fixing system that's part of the bGeigieZen. And that's basically it for me for now. Anyway, so pleased to meet you.
Yeah, Louis did a lot of the startup of the bGeigieZen, or getting the software going from the bGeigieZen Nano to the bGeigieZen, and that was wonderful, the jump you made.
It was great till Yella rescued me.
Yeah, this was all of us, not only you. Yeah, that was good. But, let's see. Michael, you want to introduce yourself?
Yeah. Hi, Steve. So Michael Beeks, I'm retired as well. 41 years as a scientist at IBM Research, working on various things, starting with in the early 80s with Josephson Junction, supercomputers, superconducting materials. My main focus was in design automation of computer chips. So we would come up with new ways of designing computer chips. What I loved about it was that we were involved in the entire chain, starting with at that time IBM had its own fabrication facilities. So we would get involved with all the way down to the physics level and all the way up to the system level. And I was also a hobbyist with robotics. Did a lot of programs with high schools and also robotics clubs. And so, interesting that somebody had this radiation detector kit, and I said, well, this was just around the time of Fukushima. It's like, the last time you should be shopping for a radiation detector is when you actually need one. And that's when I got online and started searching, and I found this team, and I couldn't purchase it. The purchasing thing wasn't working. So I sent an email to Rob, and I said, I'd be interested in helping out if you need it. And then here I am. So it's, I think, about 2 years, year and a half,
Yeah, something
like
that.
Yeah. So welcome.
Yeah, and all the snake oil salesmen come out when it's a crisis.
Yeah. Well, I mean, that was the one thing about, when Fukushima happened, it just basically all of the radiation kits getting a radiation detector at that time was impossible.
Yeah, at that time, Safecast was lucky that then Saif from Metcom had a lot of Geiger counters, and he donated a lot to Safecast. I mean, without him, we wouldn't be like what we are now. It was amazing, the support he gave.
Wow.
Yeah.
So that's a great team to be part of, and really appreciate it.
Yeah. And Jelle is the only one missing for the. Normally, we meet with 4 or 5 of us, extra people like Steve. So Jelle will come soon. Jelle is It's based. Oh, he can introduce himself. That's better. A little bit about me, and I'm about 35 years in Japan. And when the disaster struck, I was in Tokyo, and I went with journalists the next day directly to north to Fukushima area, and the nuclear power plant was still running, and there was trouble with it, but nothing serious happened. So when the accident really happened, we went away from that area. We went north, and then later flew back to Holland with the journalists. They asked us, "Do you want to come?" Yes, yeah, we will come with you. But then we come back to Tokyo. Me and my partner, sorry, I should say, my partner Yuka, she's Japanese, and when we went back, we started to talk with Peter. Peter Franke is one of the founders from Safecast, and he gave us a Geiger counter, and we went to help with a friend in Fukushima to set up a data center to give people how to say the possibilities to learn and to work. And we stayed 1.5 years in an old school. We built a prototype for a data center. And in that time, we did a lot of hardware and software development for Safecast too. So we had workshops there. And Peter and Joe and other people came over. Ryoshi was also there. And Ryoshi was very surprised by seeing hanging motherboard in the air. So air cooling, no fans, and after that we worked a lot together. So and then after this project was finished, I moved to Nara and built my own house, off-grid, self-supporting, and I kept working for Safecast, doing small projects, big projects, did admin. I do some hardware, software. My background is electronic engineer, but I studied modern dance. So it's a mixture of something. Yeah, that's basically my relation with Safecast. Currently, I'm working on the Zen and the selling and the organization from the Zen project. We are working on the scintillator project that's a bigger project for later. And surely we will need your expertise, Steve, for that. Because we are just starting, we have not much experience. There are a few people in Safecast who know scintillators well, but at the moment we started from scratch, built a new one. We have support from a guy in Romania. He built an open source scintillator called Pomelo, but I will invite you to the channel too, so you can look around the Synth channel. And then Steve can see what we've been doing so far. And if you have feedback, please for that.
Very good.
Shall we wait for yellow, or shall we just start with the things we want to talk about? Yeah, I think we can start now.
Not much from my end. Now I'm done teaching. Yeah, Steve, I was part-time teaching still at the college level, but then I decided that it was just too much of a drain on my time. It was fun, but it's time to move on. So I expect to have a little bit more time. Although ski season is starting, and that's going to take up a lot of time. That's a good thing. So just a couple of projects I have on the back burner. One is just finishing the assembly manual for the Zen. I've also been working on the idea of a simulator that would simulate the pulses from a Geiger tube and the detector. Basically trying to reproduce the actual randomness rather than the sort of a strict clockwork or like 10 pulses per second or whatever. try to reproduce the actual probability and the characteristics, of including the dead time of the recharge time of a Geiger Mueller tube. So that's for one of and that would be to allow us to test various counting algorithms or various compensation algorithms, if I could get that to a point where it's reliable enough or trustworthy enough, let's say. What else is I want to come back to the GPS. I'm not happy with the way the GPS is working. It takes a long time to lock in, and there's some mysteries of the chip or the receiver module that we're using that that I think I'd like to revisit. But of course that gets pretty nasty because the firmware for that device Michael can tell you all about it because he actually delved into it a lot deeper than I did. So that's the improvement side of the bGeigieZen. I'm also interested just in the scintillator project, but that's in the very early stages. And a side interest of mine is tritium. As you know, we have these CANDU reactors, and the heavy water very often gets converted to tritium. The Darlington reactors have a tritium recovery facility, and they sell that commercially or to whoever wants to use tritium. And well, it leaks, and as you know, it's a health hazard. Very stealth health hazard, and it would be nice to have a citizen science project to detect tritium in well water as well as lake water. But as you know, it's also a very, very tough problem. Hopefully, some of the newer technologies like the silicon photomultipliers and polymer scintillators can help with that. I wish it would be as easy as just taking a bGeigieZen and holding it above a bucket of water, but that's not the case. Anyway, that's it. That's it for me. Carry on.
Okay, so that's something I actually have some familiarity with. Because the Brookhaven National Lab used to have the high flux beam reactor. It operated from 1968 till 1997. It got closed down prematurely because the anti-nukes, showed up with the lab with pitchforks. That's a whole other story to itself. But anyway, it was a heavy water reactor. And it was a very unique reactor in that it was the core intensity was the highest flux reactor in the world at that time. And the thermal flux, it was designed, what was unique about it is the thermal flux actually peaked outside the core. So they could put beam tubes in and bring the neutrons out for experiments. So it was a very unique reactor. The lab actually holds a patent on it. But it made a lot of tritium. And it made so much tritium that every so often we had to change part of the primary coolant out and put in fresh deuterium to control worker dose. Because as you know, you can't bottle up a tritium from reactor. It just, it oozes out everywhere. So we had a whole air monitoring program and, for measuring what went up the stack and air monitoring within the building. So I'm familiar with the difficulties of measuring tritium. I'm not an expert on tritium measurement, but I certainly have, from the health physics standpoint, have a sense about it.
Do you have access to hardware for that measurement, or do you know people who could help Louis with this information?
Not really, because like I said, the reactor closed operation in 1997. And so all that expertise, anybody who knew anything about it is long gone. And certainly at Savannah River, there's people in DOE that have that expertise because they make large amounts of tritium for the weapons program. But that's really kind of the only place in DOE left that actually handles tritium to speak of, other than some other things. But that's where the production is. But I don't really, unfortunately, know anybody there. I don't think that, so to my knowledge, there's no other heavy water reactors in the U.S. and research reactors. HFBR was a one of a kind.
The other places in the world, except for the US, who could have something similar.
Well, if you have any members in India, they operate CANDU reactors.
Okay.
Yeah, CANDU is India, Korea, China,
Oh, Korea.
I think
We have people
Romania,
in Korea. We have volunteers in Korea.
and I believe Romania.
Yeah,
Oh,
Has,
Romania, right.
not sure.
that's good. Mihai.
Yes,
Mihai
but
can maybe help us in his
yeah,
institute. I don't know
yeah.
which institute does he work for? Do you know, Louis?
I can't remember.
He had
Uh,
a lot. He had a lot of information from the NSSC, I think, but
don't know.
something like that. But
Yeah.
okay, more interesting.
Anyway, so yeah, so anyway, that's a side project of mine. That's kind of like the out there thing. I keep reading up on it, and someday I'll I don't know, something like that. Something will come out of it.
Yeah, and for the scintillator project, we are thinking about how to present the data, and we are making tests for different maps and see how we're going to structure it, how to store the data, and how to retrieve it, and how to make it visual. So
Are you
that's
planning to do spectroscopy with it or just have a more sensitive instrument?
spectroscopy. That's what we're thinking of. But our database is not set up at the moment for that. So we have to think about structures and how to upload it and how to analyze it if we want to analyze it. But first, get the data in and see them.
So that's an area, spectroscopy I have expertise in. Because with the DOE, we used to call preventative radiological nuclear search, for big events like the Super Bowl or, big political conventions or, things that would attract large numbers of people. So we would support the local law enforcement authorities and the FBI to, make measurements around the venues and so on. So, inevitably you get radiation signatures of 99% of them are medical. So we did a lot of real-time spectroscopy and analysis.
Oh yeah, that would be very useful with your experience with that to find out. Yeah, great. And Michael has some updates or other things or
So I'm just getting back into it. Again, with Louis, we've been working on. So one of the things we're trying to do is develop emulators for the inputs for the device itself. And so we have a GPS emulator that we actually take one of the Zen units, and you could turn that into, instead of receiving GPS inputs, you could turn that into an emulator and feed another Zen unit, for testing, for creating a test bed. And so if we have that as an input, and then we're working on Louis is working on the input for the tube. It gives us a test bed for testing the software, and then the emulation of that or the visualization of that data that follows. So one of the things we got caught up with was the GPS unit is telling us that, oh, you've got a lock and it's a trustable lock, and then you're seeing issues that look like spoofing or jamming or interference, and it turns out that it's really because the firmware that's inside of this GPS unit, which is a black box, they give you an interface to it. The firmware that's in there is saying, oh, this looks good. But then when you actually dump out the raw data, you see that you really have weak signals that are contributing to, the triangulation. And it's just, you see these, jumps of, multi-kilometers, sometimes 100 kilometers in location readings. So an impossible acceleration and velocity. And so we're trying to create our own, trust algorithm in terms of location. So that's what I'd been working on a while back, and then I've been busy with some home projects. Just as an aside, when I went to college, my first school was SUNY Potsdam. They had a mass spectrometer that was this gigantic thing inside of a room in a basement. And the professor I was working with, Dr. Jacali, they were working on short half-life radiation. It was really interesting. He had written a book about it and stuff. It was very cool. One of those moments of hey, you should be really into these into science.
Mm.
I can imagine. Yeah.
And now mass spectrometry, the TSA has these things that are in the size of a suitcase.
Yeah.
All right.
My plans for maybe Diala, that's a good timing. Diala,
There he is.
there he
Hello.
is. We have today Steve is joining us. Maybe if you want to know more about Steve, we're recording this, so you can watch later if Steve want to tell something personally, go ahead.
Okay. At the risk of a little bit of repetition, I'm a retired scientist from the Brookhaven National Laboratory. I'm a health physicist by trade, and I've worked in radiation detection pretty much all my career. And pragmatic expertise in that is what I bring to the group here. I did spend 3 weeks on deployment with the Department of Energy at Fukushima, and I've been part of the radiological assistance program in DOE effectively in almost all of my 45-year career. So I have a lot of experience in radiation detection in the emergency response context.
Wow. Amazing. Great work. Thank you.
Indiana, you
Um,
want to introduce yourself?
yeah, sure. I'm embedded software engineer from the Netherlands. Been involved in Safecast since 2019. Currently working in infrastructure management, but not really related to uh, Safecast work, but still doing Safecast. I try to do it weekly. The past few months have been quite busy, so I haven't had much time, but I'm trying to pick it up again. So uh, nice to have more people in these meetings. So that's expertise is always appreciated.
Yeah. I think that's and then the question: did you have time to work on the software?
No, not really. No. Sorry.
No. So that's fine. I mean,
It's gonna be next week.
I understand
That
completely.
I'm so busy. It's crazy. Yeah, next week I have my holiday. Even though I have my friend visiting, she also has to work on the 22nd and the 23rd. So
Oh,
I'll
you have
just be
some time.
working, do some work for Safecast. At least work on your branch and get that merged and
Okay.
finish up the SD card functions that I was working on.
Yeah, that would be great. And if possible, the upload function, because that I would like to the bulk upload, because I'd like to use that also for other projects. Because we have to, from the API, we have to send data and receive data from the new map. Because in the map we can upload, and then if we bulk directly to to the API, that is easier.
Yeah, right. I think the bulk upload, or it's uploading the log file directly. It doesn't go through. Does it go through the ingress? I don't remember.
No, it goes first API, then it goes to ingest.
In this. Oh yeah. Okay.
No.
No.
Yeah.
If that works, that's great. So, well, I'll try to get that working. And I think last time I worked on that was last year around this time as well. So, or maybe earlier this week. But I did have a working prototype for small log files at least. The bigger ones, they do get stuck in the upload. They time out. I haven't resolved that yet. I wasn't able to reproduce it locally at least. So we'll have to see.
Is that the problem with the large files? Is that a problem because the API kind of the server at the other end kind of stalls out? Because I've noticed that when I was trying to upload just a log file, just like the traditional way, like grab the SD card and upload it through the API.
Yeah.
And very often the server is just not available or error 500 or whatever.
Yes, 503.
All right. Okay.
Yeah.
Well, I think the response wasn't necessarily a 503 service unavailable. It was more a timeout, like just lost connection after a while. Maybe we can do something upload it somewhere else, but that doesn't have a short timeout, and then move it instantly to the API.
I give you another IP from Yongling from Korea. He replicated the API and updated it locally first. And now he is in the process of applying the same updates to the current API. Then
No,
it
that's
should
great.
be really fast. Yeah. So, but I can give you an IP that you can upload to. It's exactly the same API. So then you will not have timeout. It's running on directly. I think on Amazon he has a special thing. So
okay, yeah, sounds great. I think the code is still somewhere in the development branch. It's disabled at the moment, but I'll try that next week as well.
Yeah. Okay. Great. Looking forward. If you need help, I'm here.
Yeah.
Good.
Is this meeting, is it now moved to the Mondays or still on Sundays?
Yeah, Louis was in the weekend busy.
Yeah.
So
Sorry.
No.
My grandson's on the ski race team, and they're training because the season's so short. They train Saturday and Sunday full day, and I have to be on site in case there's any difficulties. So that's my weekends. So I'll be doing a lot of skiing and a lot of sitting around in the lodge.
Okay.
To be fair, for me, the Monday is a lot better as well. So often I have on Sunday other things coming up. So if we can move it to the Mondays, it would be.
Yeah, I mean, next week, Monday, that would be fine, I think.
Yeah.
Good. I think that's it kind of for today. We're soon running out of time, so. Other things to close off with, or? No?
No. Have a good week, everyone.
And yeah, everybody, good week then. Okay.
Yep.
Bye-bye. Okay.
Sorry for being late, but thank you all for joining.
No.
Yeah.
Always happy that you come by.
Yeah.
Okay, bye-bye.
Yes. Bye-bye.
All right. Take care.
Bye.